Okay, now we start digging on percents. Now, if you look at like all the percent problems in the world and you sort of abstract them out, I think you'd find like there's like 4 types. Well, today we're going to look at 3 types. Save the 4th type for next time. So, what 3 types am I talking about? Well, here's type 1, the old find 30% of 40 trick. Well, this is actually kind of nice. What you can do is you can just kind of go like this. See that 30%? Make it a 0.30. You see that of? Make it a times. You see that 40? Well, it's a 40. And so you just multiply 0.3 times 40 and you get 12. There she blows. Instant replay. What are we doing here? We're, let's see. 1, I'm using the fact, that's a 1. That's a 1. Come on, man, that's a 1. 1. I'm using the fact that so often in a math class we can take the word of and interpret it to mean times. Whenever you take a piece of something, like half of something, you're taking half times something. 50% of something means 50% times something. And the thing about the percent is, to punch a percent into a calculator, you have to make it into a decimal first. To punch a percent into an equation or into a calculator, make it a percent. Excuse me, what did I just say? It is a percent. Make it a decimal. That's what I'm trying to say. And that's the old, to get from a percent to a decimal, remember you would go from a percent to a decimal, you would go 2 spots to the left. Exactly 2 spots, never more, never less, 2 spots. Cool. I think you know how to do these. You want to try these ones real quick? Pause. Come back. Okay, 1.8% of 120. First of all, we know the of means times. I want to take the 1.8% and I want to make it into a decimal. 2 places to the left. Exactly 2 places. Never more, never less. So 0.018. And that's going to multiply the 120. And when you do that, you're going to get what I get. I got 2.16. Bada boom, bada bing. 137% of 8. What am I going to do? I'm going to make that into a decimal. How do I do that? I slide 2 places to the left. Always 2 places. Never more, never less. That's a 1.37. Of means times, of 8 means times 8. And you work that out and you will very quickly get, what do I get? 10.96. 10.96. Now as a little mini bonus here, mini bonus, is means equals what? You can use an X if you want, just to make it look like an equation here. That's just a little foreshadowing that I've got going here. Hey, our first typo of the day. There it is. 80 is 0%. That's not what I meant. Let's cross this off. 80 is 40% of what number? That's what I meant. Okay, so 80 is 40% of what number? How can we do that? Well, remember that foreshadowing I was just talking about? That foreshadowing is here already. 80, well, that's 80. Is means equals. Is always means equals, right? This is that. This equals that. 40%. Oh, I remember. You turn that into a decimal. Of means times, and then what number? Well, you can use an X to stand for a number you don't know what it is yet. Of what number? Cool. So that's all you guys will do. Now to solve this thing for X, I guess it's not all you guys will do because now you got to solve. You need to basically, here's your X. Keep your eye on the prize, right? So you have to divide both sides by the 0.40. On your calculator, that looks like this. Take the 80, divide it by a 0.40. I write that out because sometimes people get this backwards. They take the 0.40 and they divide it by the 80, which is exactly the wrong answer. But if you do it this way, 80 divided by 0.40, you should get 200, which is saying that 40% of 200 is 80. By the way, let's do one of those reality checks in the form of a 2-sided ruler. So your numbers are on this side and then your percents are on this side, right? Okay. Now you have this number 80 and you have this percentage. Okay, the percentage side is going to go from 0 to 100. 40% would be where? Well, you got to count something like this. Here's 40%, right? 20, 40, 60, 80, 100. And these should all have percentage symbols on them. So 40% is right here. Now when they say 80 is what you get when you take 40% of what number, then this is a 0. This is an 80. Try to guess what this is. Do you think it could be 200? I think it could be 200. I really do. You could work it out exactly if you want to, but the only reason I'm doing the reality check is I want to say, does 200 seem about right? Yeah. This is 80. This has got to be more than twice that. So 200, sure, looks about good to me. I love doing those reality checks. So the two extra things here, the instant replay. Again, with the instant replay, is means equals. Always take the percent, make it a decimal. Of means times. There's a times in here. And you could use X to stand for your what. So with that, boy, does that look like a mess. Let's erase some of that stuff, huh? Yeah, let's not have it be that messy. Okay, with that, why don't you pause and try these two real quick. Like, you've tried those. That was real quick. Okay, 40 is 80%. Make it a 0.80. Of means times, and in times what we don't know, so we'll just say, I mean, you could do it this way. That looks like 0.80 times X. I suppose you could also put a big old, putting times X like that kind of bothers me. Makes me anxious. I think I'll just leave it like that. 0.80 times X. 40 is 80% of what? There we are. Now to solve this thing for X, again, keep your eye on the prize. The X is over here. What you don't want is you don't want it being multiplied by 0.8. So to take that back, you divide by 0.8. I always think of this as I want to cancel it off. So you cancel it on both sides. So in this particular problem, you always start at the top. It's 40 divided by 0.8. And if you do that, you get, what I get? 50? That's what I got? Okay, 50. Yep, it's 50. You could set up a ruler if you want to do the reality check. I love the reality check. Anyway, this one, 0.25%. All I want to make that a decimal. To make it a decimal, you move it 2 places. Always 2, never more, never less. This is going to be a point. 0, I have to put a 0 here. 0.0025. Of what number times the next number is 12. There's our formula. This time I'm dividing both sides by the 0.0025 because that's what I'm trying to cancel away from the X. So 12 divided by the 0.0025, you're going to get a big thing, 4,800. Hey, we're grooving now, eh, folks? Okay, here's type 3. This is where it's the percent that we don't know. Wait a minute, didn't we do these already? Anyway, 12 is what percent of 20? We have done these before, but let's do it. Let's go with this whole is means equals stuff. I like this stuff. This is cool stuff, fun stuff. I live for this stuff. 12 is what percent? Well, you're supposed to make it into a decimal, but I don't know what else to do except call it X. So X, what percent is X? Of 20 means times 20, so I might write it this way. 12 is something times 20. What is that something? Well, you'd have to divide the 20 on both sides to cancel it away from that X. 12 divided by 20, by the way, will come out to 0.6. Now here's the thing you got to remember. What they're saying is that, come on, piece of paper, turn. Turn, piece of paper, turn. Oh man, just turn. What are you doing? Just turn. All I need you to do is turn. Okay, here we go. Remember that this is what's in the equation. We just solved for X, so there's a 0.6 in the equation. That was a 0.6 after we turned it into a decimal, right? So you got to remember that it was a 60% before we turned it into a decimal. In other words, don't forget to slide when you get your decimal answer, don't forget to turn it into a percent by going to the right, right? Decimal to a percent is a double play. If you're going from D to P, it's to the right. Decimal to the percent. Go that way. Okay, let's see now here. So that's a big deal. How about we put a big flag on that? What do you say? And then maybe even the word, hey. This part. Don't forget, when you get the 0.6 out of your equation, that's not the percentage. You have to move this decimal twice to get the percentage. So, 2 more for you to try right there. Go for it. Pause. Rewind. 8 is what percent of 6? 8 is something of 6 times 6. So I can divide both sides by 6. That's the 6 I want to cancel. 8 divided by 6 is going to come out to like 1.333333. So that's what x is. Is it 1.3%? No, it's not 1.3%. The decimal is 1.333. That's after we made it the percent into a decimal. I want to make this decimal back into a percent. I have to go this way, right? This way. 2 places. 133.3%. 8 is 133% of 6. I'm going to prove it to you by doing one of those ruler things real quick. So the numbers are on this side of the ruler. The percents are on this side of the ruler. Let's go from 0% to 100%. I can dig it. Now, the of 6 is telling you that 6 is the whole thing. There's 6. All of a sudden, I realize that my ruler's not big enough. So the of always points you at the whole, by the way, of 6. So, and you know, that might be worth mentioning. Of means times, but it also points you at the whole, what the whole is. So the whole is 6. 8 is over here someplace, right? So this has got to be something a little bit bigger than 100%. Does that look like it could be about 133? Sure, it looks reasonable. Again, I'm not trying to calculate it exactly over here. I'm just trying to say, does that look like 133% is in the ballpark? It does. It's got to be bigger than 100%. 8 is bigger than 6. It's got to be bigger than 100%. Okay, let's get that out of the way. Next. What percent of 800 times 800 is 4? Okay, it looks like we need to divide both sides by 800, yeah? Yeah. If you go 4 divided by 800, did I do that? I don't know if I did that. I'm going to do it right now. 4 divided by 800, bada boom, bada bing. It's 0.005 on your calculator. Now that's the decimal. Again, that's the decimal. Decimals go into the equations. So if you're solving for something that's in the equation, that's a decimal. To make it a percent, you got to go exactly 2 places, no more, no less, 2 places. So this is actually 0.5%. And you know what? I think that one's worth checking with our ruler too. So let's see if we can do that. So we go from 0 to 100% on this side. Of 800, the 800 is here. So we're talking 4? yeah, that's way over here. So yeah, that's going to be something very small, a very small percentage. 0.5% seems reasonable. Okay, well, that was interesting. I got another way you can check your answer too. There's another way you can check your answer. Dig. If you took 10% of 800, you would get 80, right? You know that trick? It's the old, if you want to take 10% of something, well, officially you would take the 10%, turn it into a decimal, multiply it by the 800. But to multiply by 0.1 is just going to slide this decimal back. The 800 becomes an 80. So 10% is 800. 1% would be 1/10 of that, which would be 8. We only had 4. That's half of that. It's half of a percent. Get it? It's half of a percent. So it actually, it digs out. It grooves. It's cool. Okay, so now we've got this these 3 basic kinds of percent equation. Now those are abstracted out. It's not usually the way we talk when we have a percent application in front of us. We usually talk in terms of motors, watts, electricity, shaft power, blah, blah, blah. But what will happen is we'll usually be able to extract out a little sentence, something like this. We'll be able to extract out a sentence from what they're telling us. So let's see what we got here. A motor draws 800 watts of electricity and delivers 720 watts of shaft power. First, let's understand what's going on here. You got a motor. There's the motor. This is like a pulley over here, right? So you got the pulley and it's spinning around, and that's what's called shaft power. You know, you can hitch up a belt to a whatever and power stuff. Now to get it to work, of course, you have to hitch it up to the power company over here. So the electricity is coming in, and this spinning over here, it pushes things, right? This is what we mean by shaft power. You can hitch it up to stuff. Remember those, like a tractor, you know, it's got the thing on it. You can just put a belt on it and it'll run whatever you want, right? Shaft power. Anyway, it says the motor draws 800 watts. So that means 800 watts of electricity is coming in on this side. It's going to deliver 720 watts of shaft power. Notice that you get out less than what you put in. That's always the case, unfortunately, in this world. You never get out more than you put in. Well, in terms of energy conversions, anyway. If 800 watts goes in, you can't get 800 watts out. Some of it's going to be lost. Where's it go? Well, if you touch the motor, it's hot. So you've got heat leaking out into the environment. So that counts as a loss. Stuff like that. So whenever you change energy from one form to another, from electricity to mechanical to shaft power, something's going to be lost. So we lost 80. We went from 800 to 720. We lost 80. So, okay, that's what's going on. What's the question now? What percent of the input is the output? Well, here's the input. Electricity goes in. That's the input. Shaft power comes out, so to speak. That's the output. Okay, I'm going to interpret that equation directly. What percent of the input? Well, the input, that's over here. That's the 800 watts. Is the output? Well, the output's 720. Isn't that slick? What percent of the output is the input? You can literally translate this little phrase directly into a little equation. Now to solve that, we're going to have to divide both sides by the 800. So you're going to have a 720 over 800, which if I'm not mistaken is exactly 0.9. That's the decimal, so it's 90%. It's a 90% efficient motor. Not so bad, I guess. 90% of the electricity actually gets converted into usable shaft power. You lose 10% out as heat. That's what's going on there. What do we got here? We got another motor, and it's got 90% efficiency. They actually told us the efficiency. Okay, cool. Motor with 90%, it draws 1 kilowatts of electricity. How much shaft power does it deliver? Okay, well, we have a way of interpreting this efficiency now, right? This 90%, what it meant was that what you got out was only 90% of what you got in, right? You always get less out than you get in. So I'm going to actually write this out. It says 90% efficiency. Okay, that means this. How should I say it? 90% of the input actually gets converted to the output that you want. The rest is lost. So 90% of your input becomes output. Okay, that's the phrase, and that was the hard work, is being able to extract that idea or to remember that idea. That's how efficiency works. There's a certain percentage of the input that you can convert to the output. Okay, now hang our information on there. Let's get a new color. 90%, that's this. Of means times, of the input. Okay, well this is a motor again, so it's the same diagram as up here. It's sucking in, that's going in, 1.8 kilowatts of electricity, so I multiply this by the 1.8 kilowatts of electricity, is, I guess, the output. How much shaft power does it deliver? That's the output, that's the X. So 0.9 times 1.8. Please tell me I did this. I didn't do this. All right, Mr. Calculator, I need your help. 0.9 times 1.8 comes out to 1.62, I guess. 1.62, and it was kilowatts here, so it's kilowatts here. 1.62 kilowatts of shaft power will be delivered. Again, you always get out less than you put in. You put in 1.8, you're not going to get quite as much out. 1.62 seems reasonable. So these are fun. Here's a generator. What's a generator? Generator is kind of like the opposite of a motor. A generator goes like this. It might look like a motor. DC generators sure do. In fact, a DC motor can be used as a DC generator. Doesn't work for AC, but it does work for DC. So actually, since I'm using it, I'm doing it the opposite way. I'm going to actually draw it backwards. Not that you have to turn it around, but I'm going to. So what we have here is somebody has to run on a wheel out here, right? That's our fan belt or whatever you want to call it. This is the, what do we call it? The shaft work. That goes into the generator. And what comes out is, I guess I'll show 2 wires or something. This is electricity coming out. That's how a generator works. And if we say the generator is 88% efficient, well, that means that 88% of what comes in is converted to the output. In this case, what goes in is the shaft power, and what comes out is the electricity. So generators, motors, you got to pay attention to what goes in and what comes out. But other than that, it's the same idea. A certain percentage of your input will be converted to the output. So only 88%. It's always less than 100%. What numbers did they give us? They gave us a generator with 88% efficiency. Yep. Of means times. The input. It's used to generate 400 watts of electricity. That's not the input. That's the output, right? 400 watts is going out. They're asking us how much is going in, how much shaft work is going in. That's an X. The input, don't know, it's an X. But that's converted to the 400 watts output. So notice what we're going to do here to solve is we're going to have to take that 400 and we're going to have to divide it by 0.88. And what's that? 400 divided by 0.88. Boom! I said boom. That's about a 454.5 or so. And that would be, what do we have? Watts? Watts. That's how much you would have to, we solved for the input. That is how much you would have to put in. That would have to be the shaft work. That's the input, basically. You have to put in more than you get out. If you want to get out 400, you're going to have to put in more than that because you're going to lose some of it in the translation, so to speak. You always lose some in the changing the form of the electricity there, of the energy, I should say. By the way, notice we did not multiply anything by 0.88. People get very happy multiplying, you know, they're doing percentage problems. They like to turn it into a decimal and multiply it by something. People are very happy to do that. And then they go looking for a number. Where's a number I can multiply it by? Okay. Well, if you were to take that approach, you'd be multiplying what? I guess 0.88 times 400. But notice that's not what the solution is. There's no times 0.88 times any number. It's 400 divided by 0.88, actually. So be very careful out there when you're flying too fast. You don't want to fly too fast, not with percentages. Okay. Well, that's a bunch of efficiency problems. How many more problems we got? 1, 2, 3, 4. 4 more problems. Wow. Okay. But there's some variety in life, and that counts for percentage part of life too. What do we got here? 12 resistors in a batch of 500 are defective. Hey, turn the paper this time. Come on, man. Okay. And then the question is, what percent are defective? Okay. So the question we want to ask here is basically 12 out of 500. 12 is what percent of 500? It's 12 out of 500 that are bad, but we want to know that as a percent. So 12 is what percent of 500? Okay, that's our little phrase. 12 out of 500 is 12 is what percent of 500? Here we go. 12 equals what percent times 500. Cool. Divide both sides by 500. Also cool. 12 out of 500 is going to be bada boom, bada bing, bada bing, bada boom, bada bing, bada bing. That's not it. 12 divided by 500 is boom. I said boom. 0.024. Which is the decimal. So again, as a percent, 2.4%. 12 resistors is about 2.4%. reality check. 10% of 500 is 50. 1% of 500 is 5. But we had more than 5. We had 12. We had like twice as much. So not 1%, more like 2%, 2.5%. See, it seems to be working. So I invite you to use the old 10%, 1% trick to kind of check your answers sometimes. Sometimes you can get a pretty good ballpark estimate if you just say, well, what's 10%? Well, what's 1%? Well, it's got to be somewhere around twice that. So it's got to be about 2.4%. So if you got an answer like 127%, you would immediately say, no, let me think about that some more. Okay, let's see. What do we got here? Sales tax. Everybody loves sales tax. So the sales tax is, what's it saying? 7.375%. What that means is that 7.375% of your purchase is kept as tax, right? You always want to try to make some kind of a little phrase that has maybe an of and an is in it. If you can take what they say and translate it to something that says, okay, so what is what then? Well, I know that 7.37% of what? Of my purchase is going to be my tax, right? 73% of my purchase is my tax. So I wrote it out. Now we can start solving already. Make this into a decimal, slide it 2 places to the left, exactly 2, no more, no less. 0.073% of means times your purchase was, what did I have there? I had an 84.40, so that will go there, is kept as tax. That's what we want to know. What's the tax? Well, that was a nice equation. So the old, if you want to find the percentage of something, just make it into a decimal and multiply. 0.07375 is the decimal, times the 84.40 is the purchase. The tax comes out to about $6.22. Is that what I got before? Good, that's what I got before. So you can do tax things this way too. The sales tax downtown is a little more hefty, 10.125%. Okay, now we can use the same idea again before I even read. We know it's a tax problem. I can use this same idea. I can say 10.125% of the purchase price is the tax. That's the structure of this problem. 10.125% of the purchase, dollars purchase is going to be the tax. So we can start already. We can start looking for what did they tell us. Well, I know that 10.125%, if I slide the decimal back 2 places, it's going to be 0.10125. Okay. Of means times. I put my purchase here. What's my purchase? They're not telling me. They're asking me. What was the purchase? Oh, so that's going to be my X then. Is, and then the tax. I hope they told me the tax. They sure did. They said I paid $37.14 in tax. I hope that wasn't me. So anyway, there we go. There's our nice little formula. And once you get your formula, you can just say, well, I got to get the X by itself, so I have to cancel off that 0.10125 thing. So I have to take 37.14, type that in first, then type the divide by symbol, then put the 0.10125 in. And I think I did this already, and I got $366.81. That's a lot of whatevers. That's a lot of wool socks. A lot of Hershey bars. All right, one more. You want to try this one yourself? Just try to make a little phrase. Try to interpret the phrase. Try to hang the numbers and the information and the X onto the phrase. Okay, here we go. So the phrase is the same. It's, well, actually, we don't know what the tax is, but we know that, I'm going to write it this way because it's flowing off my tongue this way. Tax is a percentage of the purchase. We don't know the percentage, but we know that this is how it works. You take a percentage of the purchase to get the tax. The tax is a percentage of a purchase. Now, you could have written something down that was slightly different, and that's fine, as long as the meaning is the same, that you take a percentage of the purchase to get your tax. That's what matters. Because if you have that structure, then it's going to solve the same, guaranteed. So what do we got here? $3.54 tax. That's right there. Is a percentage. What is the percentage? We don't know. So we don't know the percentage of the purchase times the purchase times the 78.75. Just like that. Now, if you're more comfortable, you could, of course, write it this way. Put the 78.75 and have it multiply the x like this. That's just like semantics, though. It doesn't make a big difference. What is important is that in order to solve for x, you have to cancel the 78.75 on both sides. This is what's important, that you're taking the 354 and you're dividing it by the 78.75 to get, what I get? What did I get? I got 0.04495. Now remember, it came from the equation, it came from the calculator. It's a decimal, so the percentage, to go from a decimal to a percent, you go to the right 2 places exactly. It's going to be a 4.495%, or for all we know, it was a 4.50%, something like that. Because they always round the, this might have been like it was supposed to be 354 and another 0.5 cents or something. I mean, who knows? So but anyway, it's somewhere around 4.495% or so. Maybe it's 4.5. I don't know what it is, but it's pretty darn close to that. Okay, so I hope you're enjoying these nice percentage problems. Percent efficiency is something that you'll see. Tax is something that you'll see, maybe not just in your major. Stuff like that. Yep. That was fun.